वालेकुम स्टूडेंट, आई एम जायद खान। आज का हमारा टॉपिक है टर्मिनल वेलोसिटी। स्टूडेंट, आपने अब अक्सर ऑब्जर्व किया होगा, व्हेन ऑब्जेक्ट्स मूविंग डाउनवर्ड फ्री फॉल देयर इज ओनली वन फोर्स एक्टिंग, दैट इज कॉल्ड its weight. So when that object is moving downward, its speed is increasing and increases. So a stage is come when its speed is reached to a maximum point. So in that point, another force which is called drag force is acting on it. So the object's velocity become constant, and that constant velocity is called terminal velocity. Terminal velocity is a constant velocity which is maintained or contained by an object when that object is moving in a viscous medium under the action of gravity. जब कोई ऑब्जेक्ट जो है किसी विस्कस मीडियम में ग्रेविटी के साथ जो है मूव करता है, तो इस दौरान जो है इस पर एक ड्रैग फोर्स एक्टिंग करती है, और दैट ड्रैग फोर्स इज इक्वल टू द वेट ऑफ द ऑब्जेक्ट. When two forces become equal, then the velocity of that object become constant, which is called terminal velocity. Let's suppose we consider a raindrop at a certain height h. As the raindrop is moving downward, then its speed is increases and increases. So when it reaches to point V, here a drag force which is called viscous drag force is acting on the raindrop. Here the drag force is equal to the weight of the drop. So both forces become equal, but acting in opposite direction. So after that the raindrop is reached the ground with a constant velocity, and such a constant velocity is called a terminal velocity. And that terminal velocity is obtained in objects at that point when its speed is reached a maximum height, a maximum point. So the raindrop is velocity is increased as move downward. Let's consider a raindrop is moving with the speed is 0.02 meter per hour. So its speed is very less. As move downward, its speed is increased 0.6 meter per hour, and move more downward, then it's reached 1.69 meter per hour and 14 meter per hour. So it means that at 14 meter per hour its speed is very maximum. So here the another force which is called drag force is acting on the drop. So here the drag force is equal to the weight of the drop, and Fd is equal to W. And we know that the drag force is equal to 6 pi eta rv, and W is equal to mg, where 6 pi is constant, it is the viscosity of the water, r its radius, and v is the volume. So we can cancel 6 pi eta r both sides. We get Vt is equal to mg divided by 6 pi eta r, where Vt is the terminal velocity of the drop. Here we can find m is the mass of the drop, and from the density we know that density is equal to mass per unit volume, or m is equal to rho v. But we know that the volume of the drop is v is equal to 4 by 3 pi r cube. So we can put this the volume value equation number 3 and equation number 2. So we can get the mass of the drop. So if you put in this value, we can get that m is equal to rho v, where v is equal to 4 by 3 pi r cube. So the required mass of the drop is 4 over 3 pi r square density. So equation number 4 is the mass of the drop. Now we can put this equation number 4 in equation number 1, so we can get the terminal velocity of the drop. So terminal velocity is equal to mg divided by 6 pi eta r, or Vt is equal to 4 over 3 pi r cube rho g divided by 6 pi eta r. So we can cancel 6 pi, cancel r with r cube and 5 with the 5, and simplify 4 and 6. So we can get the required terminal velocity is equal to 2 over 9 r rho square g divided by eta. Here 2 over 9 is constant, which is the digit, rho is the density, g is acceleration due to gravity, and eta is the viscosity. So all three are constant. So there is only one factor which is called radius. So the radius of the drop is directly proportional to the terminal velocity, and terminal velocity is directly proportional to the square of the radius of the drop. Here another example of the terminal velocity is paratrooper. When paratrooper is jumped from airplane, they initially not open its parachute, because in this point they are moving free fall. There is only one force, that is called weight, is acting on it. So its speed is increases as it moves downward. So they are instructed to open a parachute at that point where its speed is reached to a maximum. Here we can see that its speed is increased to 0, 1, 2, 3, 4 as given in the figure. When it's reached to become maximum point, then they open its parachute. So when they open its parachute, then drag force is acting in upward direction and weight is acting downwards, so they reach the ground with a constant velocity. So that constant velocity is called terminal velocity.